Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran Ayub, and I'm joined by my co-host and best bud, Erik Onerheim. Together, we're the two TypeScript fools. Welcome to the show.
Hey, before we get started with today's episode, I wanted to let you know that SquiggleConf is going to be happening September 18th through 19th at the Boston New England Aquarium, and you can get your early bird tickets now, and if you're a speaker, they're accepting submissions through May 23rd, so make sure you submit your talk. All right, back to the show. Hello, it's episode 13. We are talking with Dimitri of Doom in TypeScript fame.
Yes, this is something that we've talked about before, and we said, hey, could we get Dimitri onto the podcast? And we ended up succeeding in that regard. Hopefully it goes well, but why don't we just start out with a little bit of news? So Erik, we were together this past weekend at VGMCon. How was that?
Yeah, we spent a lot of time in a booth together in a room that was very hot and sweaty. It was great. We showed off 4 of our games, and we'll link those in the show notes. I don't need to go through them, but 2 of them we're going to publish this year, knock on wood. And I think it was a good showing. We got a lot of good feedback. I have some really fresh bits that I'll be showing this week at the Independent Games Developer Association Twin Cities playtest event. Mm-hmm. And you should come if you're in the Minneapolis area and play our game.
Yeah, that sounds fun. And you also just published a talk on YouTube for
I did.
Learning shaders.
I did. I am a madman, and I decided the week before we had a big con to also agree to give a technical talk about how to program shaders. So that's a lot of fun. In the talk, I'm very over-caffeinated, and I forgot to take my meds that day, so it's very entertaining. So you should watch.
Nice. That sounds fun. What else is going on?
PSA, do your taxes.
Yeah, I finished mine. It's nice having a CPA that will do them for you. I just have to prep everything, send it over, and then they take care of it. This past week, I mean, like we said in the last episode, we were super busy. So all of last week, I was basically like in a cave in my office trying to finish my 2 courses. So I went from like start to finish for one of the courses, which is only like 20 minutes, but still it's quite a bit of work. So I just published my testing .NET MAUI apps course, and then I also published OpenAI Deep Research. So if you are interested in either of those, we can link to them, but they're kind of niche specific for if you're a .NET developer and you use MAUI, you might check out that course. Or if you are an OpenAI subscriber to ChatGPT, I go through how to use deep research effectively. And surprise, surprise, actually what you learn in the deep research course is how to be a better thinker, not actually how to like have AI do thinking for you. So that was one of the big takeaways that I told people. But anyway,
I'm glad.
Yeah, there's a lot of nuance there, and that's probably an entirely separate episode of how to deal with AI in this day and age. But our guest, Dimitri, do you have any cool news to share? Anything going on in your personal life or professional life that you are excited about?
I'm going to Iceland.
Ooh.
Yeah, never been to Iceland. And my son is very young, and he's at that age where lava is like the very coolest thing that could ever exist ever. And we thought, like, let's just take him to see some lava. And there's like volcanoes exploding right now. So yeah, in the background, if you hear any ruffling, it's because I'm packing bags and stuff. And I'm just kidding. But yeah, that's going to be something coming up here in a second. It's going to be kind of cool.
I'm so jealous. We have only ever bounced through Iceland. And every time we're like, we need to vacation here.
Mm-hmm. It's from Michigan. It's actually only like, it's about the same distance as LA. Like it's really not that far away in the scheme of things. I think of it as being a very distant land, but it's not.
Yeah, if you get a chance, we stayed at the Blue Lagoon, which is like a hot springs spa,
yeah.
And they actually have a direct bus from the airport to Blue Lagoon because a lot of people have, 8-hour layovers. And so you can do the entire trip to Blue Lagoon within your layover. That's what we did when we were on the way to France, and highly recommend it. But unfortunately, we had a friend go recently, and because of the volcano stuff going on, they actually had to close Blue Lagoon for that weekend. So he didn't get to, but
We did sign up for those things, but it's really funny in a lot of the like even like car reservations and hotel stuff. There's a lot of stipulations that are like, if there's a volcano eruption though, and they will opt out of whatever they sold you. It's kind of funny.
Well, Dimitri, do you want to give just a quick intro to yourself for any listeners who just may have been living under a rock and have not heard about your famous Doom and TypeScript types? Like, who are you? What are you about? And can you tell us a bit about what you've been working on?
Sure. I'm Dimitri. I'm a software developer from Michigan. I've also lived in Massachusetts for many years, so some ties there. I've been working in the domain of TypeScript for a long time. Actually, before TypeScript was even a thing, I was doing, jQuery development and stuff back in the day. And then ES5 happened, which is a version of JavaScript anyway. And I thought this couldn't be any cooler. And then Flow and TypeScript, two supersets of JavaScript appeared, as well as others that also died, like Elm and, CoffeeScript was there for a while and some other things. So I've loved languages, and I've been a aficionado of these things. I actually don't have any formal education in software engineering. Maybe we can get into it later. I have 4 degrees, but none of them I've never taken a software class before. So I like learning. Everything I learned about TypeScript and JavaScript has been kind of like on the job in the moment or wherever. I love listening to things. Thank you for doing this podcast, by the way. I hope more people, I'm so happy that this is happening and you guys are putting the effort in, because this is exactly the kind of thing that I got the most value from throughout my career is what you guys do.
Oh, well, thank you. That made my day. Thank you.
Yeah, I think actually the only person with a formal computer science degree here related to anything programming is Erik, because I was the same way. I actually have a management information systems degree and entrepreneurship minor. So nice. Again, like I was doing freelance web development as a teenager. That's how I learned some of that stuff. And then throughout college and stuff, I just work on my own apps, or that's how I learned .NET. And then that's how I got my internship. So during my career is where I really began to become a professional software developer.
Well, maybe the joke's on Erik, because unfortunately, a lot of programs around the country, they don't spend a lot of time talking about the internet or JavaScript or HTML or CSS or anything you need to be aware of to be a web developer. And I think web development is a fairly large segment of the market.
No, I 100% agree. Nothing in my education prepared me for what I actually do. Everything I've learned on the job, except for maybe a couple rare situations where there's an actual computer sciencey thing that I know, but it's pretty much I've learned it on the job.
But I was just going to say that the funny part is that your computer science stuff probably relates more to your game dev hobby than it does for your professional software development.
Makes sense. That is how it goes, though. There's a joke somebody put in one of the comments that on the Doom video that the app devs yearn for game dev, which I thought was cute. So I think what I'm about, to answer your second question, I love the community aspect of Michigan TypeScript. So Michigan TypeScript, for those who don't know, is a YouTube channel. It's a meetup. It started actually as a meetup here in Michigan, and then we began posting the videos. And one of those videos was about pooping on TypeScript enums, and it got a lot of attention. And we thought, oh, okay, this could be cool. We could do more stuff. And then I did a brutal, relentless 300 video series where I posted 2 videos per day for 6 months on the TypeScript type challenges. So that was a fun experience too, to kind of expand the audience, and it's grown since then. So I really like this element of things where people can get together and learn and grow. And I think as a software engineer, I'm lacking this. One of my other degrees I mentioned is kind of boils down to helping people. And I don't feel this feeling of I'm doing anything good for the world sometimes. In fact, I've never worked for a evil megacorp, but I've known people who do. And they've told me you get this feeling of I don't know what kind of drone strike software this is going to be rolled into later. And you don't really know where the code goes later. But when I make a video or when I, work with somebody to accomplish something, then that's another reason I like dev tools, which is another aside we can get into later. But when I do these kinds of activities, it makes me feel really good, like I'm doing something good for the world that, people are able to learn from even years after I did it. I learn along the way too. For those type challenge videos, the last one is JSON parsing, making a JSON parser purely in TypeScript's type system. And I was sweating. I was so nervous the day that we had to record that, because the whole time leading up to that, I kept thinking, well, surely by the end, I'll know how to do something like that. I must have gained the skills by that point. And then it got to that day and I just didn't feel like I could do it. And then 3 hours later, it was a 3-hour challenge. Yeah, it's all there. It works.
I definitely want to pick your brain about that, because maybe I should just watch the video, but I have no idea where I would start to do that.
It's kind of weird, right? I mean, at the end of the day, that's where, I mean, this is actually a good segue into the Doom project too, that like where to start is one of the things that I think plagues us the most as software engineers. And what's funny about the Doom project, so what I did, to, if anyone hasn't heard it in short, is I got Doom running, the full game engine running purely in TypeScript's type system. So no JavaScript code whatsoever, not a lick of it, nothing. It's all types. So there's like a type, and then there's a that, can take an input, which is another type, which is all the data and source code of Doom. And then when the type checker checks that type, it returns a frame of the screen. That's the result of type checking it, is a frame of the screen. So like, I think that one of the questions that I never asked myself was, how should I go about this? And the reason is really simple. There's this thing called the halting problem. There's another thing called the Turing complete. And these two concepts I've always had hot takes on. And I just never really have felt comfortable with the idea that Turing complete means a lot. So I don't want to get too deep into what Turing complete is. We're going so many tangents here to cover, but some people have noticed in the past that TypeScript's type system is Turing complete. And if you'd like to learn more about that, I think maybe it's better to just Google it than me explaining it. But it's a fact of any software system that you could describe mathematically, that it can do any computation theoretically with given an infinite amount of time, an infinite amount of resources. And a third thing, which nobody talks about that I didn't know, actually it doesn't include the definition that it can loop on its own. So there are Turing complete systems that you have to poke them to say, okay, do another iteration, do another loop, do another thing, do more work, do more work. They can't do that on their own, but they're still considered Turing complete. Anyway, baloney. It's baloney. I have never felt comfortable with that being a useful anything. So years ago, people said, oh, TypeScript's type system is Turing complete. And people said, oh, that means you could do, XYZ, you can run Doom or whatever. And I've always thought, what a bunch of nonsense. It's garbage. There's no way. There's no way. There's no way. There are going to be lots of blockers, because if you do like really intense programming in any domain, you're going to find there are limits that, like, I think the art of our field is often figuring out the limits that you didn't know were even limits. You have these assumptions you made about software systems that you didn't even know you made. And someday you hit those problems and you're like, oh man, it's like, this is actually not going to work because there's some limit. There's a maximum size of strings in JavaScript. There's a maximum length of an array in JavaScript, the maximum number of objects, properties that you can add to an object. Even BigInt, the BigInt number specification, the point of BigInts is that it's arbitrary precision arithmetic with no limit on the size of numbers. Those have a limit too. And they have hardware limits. They don't have theoretical limits. So the spec doesn't have a limit, but there are real limits. We have a limited number of atoms in the universe. So it's like, I don't know. I'll pause there, but was kind of the formation of this idea, was like, let's just find the limit. That's all. I didn't actually have a plan of like how to accomplish this, because I didn't think I would need one.
With that in mind, is like if we said like Turing completeness, we added an addendum to it as like practical Turing completeness. Is that now running Doom? Is that okay?
So here's what's funny. I would have said no before the video came out. But then I learned a lot when people would share their comments, and I saw people arguing in Reddit and other places too, not just the video comments. And I learned something really interesting, which is that the Doom engine itself, like the game, like the part that you can play with your mouse and keyboard, not some source code, but like you can construct a Turing machine in the game with like a series of gates and doors and stuff. There's like a way. So someone has shown that the Doom engine itself is Turing complete, which I think is game over, because now what that means is actually that useful measure is Doom complete. If it can run Doom, and I would posit that run Doom means generate one frame. If it can boot the game, boot the engine, load up the sprite and the players and the enemies and the all the stuff that you need to play the game and the map and the everything, if it can do that and get one frame out in a human lifetime, let's say 100 years or something, if in 100 years it can do that, then I think that separates. I think people are not aware of how many things that opt out that we consider Turing complete systems. There are many Turing complete systems that can't meet that definition. And I would say those are not really useful. It's interesting maybe, but like that's where it ends for me. It's not that interesting. Doom complete is the new meta.
I love that. I'm going to use that from now on.
Please do.
But is it Doom complete?
Yeah,
right.
Exactly. That's exactly what I said too when we were talking about this, that being able to run Doom seems like that's what the milestone is. Like that's the measure. Do you want to maybe talk a little bit about how you actually were able to do it? Because it sounds like you approached it with the mindset that this is just not going to be possible. And then you must have hit roadblock after roadblock. So do you want to just maybe, you just want to share maybe what some of those initial roadblocks were and then how you were able to overcome that?
Like the first one on the first day was, well, how would I even show a frame of Doom anyway? Like, let's say I had it now in my hands. How would I even make that how does that make sense? Because in TypeScript, there's this funny thing where there's two big problems. The first is that if you take a string and it has new lines in it, the way the goal, the meta goal, like the big goal would be you hover your mouse over a type and like a frame of Doom comes out as a type hint, like IntelliSense, which actually is what I ended up achieving. But there's two problems, which is like, how do you get new lines to work? Because the way it works now with template literal strings, if there's a new line, it'll just do like, \n, and then it just spits it out. So like, okay, well, that doesn't, you need like rows and columns of cells, of pixels. So that's not going to work. Well, I figured that out. You just make an object. And there's a trick, as long as the numbers in the object are alphanumeric, it will sort them. But if you have actual numbers, it will sort them differently. And of course, if there's the numbers, like 1 is 1 digit, 10 is 2 digits, and 100 is 3 digits. So then you have to like align them somehow. So how's that going to work? So I'm like, okay, I'll just put a 0 in front of everything. So the numbers will be alphanumeric. So the first slot is 0000. That's the first line. The next one is 0001. And the last one is 0199 because there's 200. It's 300 by 200 is the resolution of Doom. Okay, well, that was it. It was like one day later. I was like, oh, okay. I had a little thing. I drew a little ASCII heart and I put it on the screen. I think that was in the video. Yeah. So it's like, okay, well, that's not a problem. I guess I can find a way to do that. So it just became it was like a game of, there were many days in the project where I was so excited because I was like, yes, I did it. It's over. I'm done. I can sleep again. It's over. I found it. There's no way I will ever get past this. This problem that's right here in front of me it's just immovable wall. And I cannot, this is it. This is what I've been looking for. And then like, I'd go to bed that night or I would drive somewhere or I was, it was always on my mind. And I would think, well, if I could just do these other 4 things, these other stupid 4 things that are just like a really bad idea. But if it were possible to do those 4 things, then that thing that I thought was impossible is now possible. And I'm like, okay, I'm just going to go down the path of each of those 4 things and just go look into them. Surely there will be a problem somewhere. And it just kept going. Then each of those 4 things would themselves open up 2 or 5 new challenges. And it just kept going like that. And there was a point at which it was like really amorphous problem where like, I don't even know what I'm doing. I just know what I'm doing today. And I hope that's something that people get out of hearing the story of this project is it would never have worked if I had a plan. Like, even something resembling a plan would never have been possible. Also, I needed to be really ignorant and like not know how hard this would be was an important element.
Oh, sure. Yeah, it's like the next logical step and you just keep following it until you hit the end.
Yep. I just focus on the very thing that I have to do this moment and don't even think about. I had an extremely, one thing I did right that I also think is a cool programming win is I had an extremely extensive test suite from the first second. The first line of code was a test, asserting inputs and outputs. And I kept that up the whole time because I knew that if it ever got to the point where I was like a million instructions deep and I needed to like debug some memory corruption, something, that would be game over. But for the worst reason, that would be game over because I screwed up, not because it's not possible. And I was really afraid of that.
You're building an emulator. Like
full emulator, yeah.
Yeah, you're building an emulator in probably one of the more challenging languages to do it in.
Right.
And if you implement an instruction wrong, how do you debug that?
Right. What's hilarious, and this is a little adjunct video that I posted on the channel. It's called the Doom's Final Boss. That also ended up being wrong. I did one time have to I was joking, a million instruction deep. It happened at like 980,000 instructions. But I did actually have a memory corruption because of a mistake, and a mistake that wasn't covered by a test, which is like, because it was a really weird instruction. It's like a 1 out of the 160 instructions, there's like 2 that are really bizarre. And I didn't really know how to test them. So I didn't have a lot of coverage, but anyway, and I did have to debug it. And it was just such a wild ride doing that because I was already and it ended up being like a week before, like that was just before the very, very end. So I knew that I was really close and I just had to do it and I figured it out. So I'm very proud of that. I'm glad that thanks to Mark Erickson, the Redux maintainer, is a good friend of mine. Mark was patting me on the back in a private channel that's now public on the Michigan TypeScript Discord. And I told them, like, I just had this, guys, most intense debugging journey of my whole career. This is it. This is the craziest thing. This debugging session was out of control. And he's like, like, Dimitri, record it. Just stop talking to us and record it and show people. Maybe you'll want it later, maybe you won't. And I'm so glad that he gave me that advice, because it's cool to look back on it now. Like I've watched it, of course, and I'm just like, I don't even know what I was talking about. It was just so in the weeds.
Yeah, and I think it would be interesting for the listeners to hear a little bit of some of the details of how Doom actually runs.
So Doom is written in C. It's written in an old version of C, actually. It's written in C before there were even Booleans. So in those days, you had to make like a type alias to Boolean and then alias 0 and 1 to that. So it's pretty primitive. And I had a lot of approaches that I could have gone with. And I had never worked with C. I'd never written a line of C in my life. I've been afraid to most of my career because I'm not good enough. I don't think it's what do people call it? Imposter syndrome. I don't think I have a lot of imposter syndrome. I think I know my limits. And I do see there as being a difference. Like maybe I could potentially learn C. It's always been something I knew of myself, but I have been afraid to, or to take the time is maybe a way to put it, independent of what other people do with their time. So I had to learn how to work with the C code of Doom and massage it into something that TypeScript can begin to understand. And there's a lot of ways I could have done that. Actually, someone later pointed out to me, Dimitri, you could have just targeted assembly. Like you could have compiled the Doom C code into assembly and then made some kind of machine that runs assembly within TypeScript's type system. You didn't have to do WebAssembly, but I didn't know any better. And I had also never touched WebAssembly before. I'd never seen WebAssembly code. I didn't really know a lot about it. And I think that ignorance helped me because I found semblances of things within WebAssembly that looked like it could work. So I knew that I saw other people compiling Doom from the C code to WebAssembly. And I saw that JavaScript has a WebAssembly runtime that you can take that WebAssembly artifact. It's just a single file. And that's actually really important. I'll get to that in a second. You take that single file and you run it. And you have Doom in your browser or wherever. So it's like, okay, there may be something there. WebAssembly has an interesting feature, which is that instead of like regular programming languages that have, you have statements and you have expressions and you have all these things that you can do with variables, WebAssembly doesn't have any of that stuff. WebAssembly just has instructions. Kind of like if you've ever done assembly, which I also haven't ever done, but I've seen it at least. And the instructions are really simple things. They're like, add these two numbers, multiply these two numbers, subtract these two numbers. Like they're very basic things. Some of them get more advanced, like, shift left, which means take all the bytes and slot them over and then like add a 0 on one side. And they're kind of like graphical things that almost you can do, like you had building blocks in front of you. And if you could just, the thesis was, if you could just build a machine inside of TypeScript that can take those instructions and like do the work that they tell you to do, in theory, you could end up with a blob of memory and a pointer that points to the string of a frame of Doom. So the string part was actually done in the Doom engine. I did make some small modifications to the Doom engine just to kind of like get rid of all the stuff that I don't need or don't want to deal with or compile in. And the one change that I made is I made a graphics driver that instead of outputting pixels, it outputs ASCII. Now, what's funny is the Doom engine is really modular. So there's actually only really one file you need to change to do that because Doom itself doesn't even run on pixels. Doom has a palette of 256 colors that are acceptable colors to present in any pixel on the screen. And at the last second, so the engine is talking in terms of palette values all the time. And then at the last moment, when it has to push it to a screen to buffer it so that you can see it on your display, then it turns it into a pixel. It is literally the very last thing it does before it shows it on the screen is taking those palette values so the engine itself actually doesn't even know about pixels. So they're like, oh, okay, that's actually pretty easy. I can do that. So high level overview, that's how it works. You take the C source code, you compile it to WebAssembly. I used standard off the shelf stuff for that. I didn't write that part, but the WebAssembly is then converted into a format that TypeScript can understand, which is basically objects and arrays of instructions. So there's like literally an instructions array and it has an object in it and the object has two properties maybe, or it has, kind add or something. And so I can discriminate unions with TypeScript types to differentiate, almost like a switch statement to decide where to send the code on any given instruction. And I made a machine inside of TypeScript that understands all of those instructions and will do the work that they say to do. In the end, just like in regular WebAssembly. So a lot of people, I didn't know this, but I think a lot of people don't understand this about WebAssembly. Like, because WebAssembly doesn't have strings, it doesn't have Booleans, it doesn't have objects or arrays inside. How do you an easy question that I had originally was, how do you get a string out of this thing was like a question that I had in the beginning. Like forget about TypeScript, like in a regular WebAssembly program. Okay, here's how you do it. You run the program. It gives you back a pointer address, which is just a number, but you have access to the memory. You go look up that pointer in memory and you just read bytes. And you know in advance that there's a byte encoding that they're like ASCII, which means like, I don't know, 96 is A and 97 is B and 98 is C, like that, or whatever it is in ASCII. I don't know. So you have this pre-understood mapping from numbers to get back to strings, characters, and you keep reading like that until you hit a 0, which is what a C-style string is. I'd also heard that before. I didn't know what that was. That's what it is. And then when you get a 0, that's like the signal to the thing that's looping over the memory to say, okay, that's the whole string. You can stop now. You go, okay, you stop, and then now you're in JavaScript and you return. So same thing. The output of this system is actually a TypeScript type that returns a number. And the number is the pointer address in memory. And the memory is just an object that has all the memory addresses. And then I have another thing that wraps that as a finishing step that will go take that memory address and then boop, 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 boop. It'll just pop through all the memory addresses, picking out those byte values, and then assemble them into that object we spoke about in the beginning and return it to you in your IntelliSense as you hover. Yeah.
So really, you did a lot more than just get Doom running. You made a WebAssembly runtime in TypeScript types. And I'd actually say that you're probably very qualified to write C now, because all that C is like, it's all numbers all the way down. And we just agreed collectively that they mean something other than numbers.
You know, someone on Reddit said, or I think maybe it was Twitter or something, said like, okay, this guy may have, done most of it in TypeScript types, but there's no way it's all in TypeScript types because there's no main function in TypeScript types, and you need a main function in order to run anything. And when I said back to, I was so happy to get that comment because actually I thought that same thing. And it turns out the main function is just an abstraction too. Everything here is an abstraction. It's just like you can just keep pushing, and like there is stuff underneath the main function in C or in Rust and programming languages that have that convention in Go, but you just don't have access to it. It's like that's where the barrier, that's where the line gets drawn between what you can do and what you can't do. But there is stuff underneath that. And like I had to learn how that actually worked. Like there was a day where I was like, okay, wait a second. I have the machine. Let's say it can do all the instructions I needed to do. Great. How do I like turn it on? Like how do I like power it up? Mm-hmm. How do I like bootstrap the machine? And I had to like figure that out, and like there is a way. There is a way to do this, and turns out a lot of people have figured this problem out, like 65 years ago. But I had just never had to deal with that kind of a level of questioning before, that kind of low level understanding. Yeah.
I'd say you've earned an honorary computer science degree for sure. Like this is like you have implemented a von Neumann architecture, WebAssembly runtime. You've implemented a virtual machine that will run a program. And it's like, I think you've earned it. And one thing that that I wanted to ask is like, okay, as far as I remember, you went through the spec and implemented it from the spec.
Yes.
Like, how was that? Did you find any like bugs in the spec? Did you open any bugs against the spec?
It was very challenging. Thankfully, I am a low-key functional programming nerd, and not to rag on Ramda too much, but there's this, maybe for those who know are already laughing, I'll give you a second to stop laughing. Ramda is this JavaScript library that does a bunch of functional programming stuff, and Ramda has a spec in a sense. There's this thing called Fantasyland that they also adhere to. It's real weird. Functional programming is its own world, but they use this special syntax for like describing transformations of like types and different things. And I think I had gotten used to that there. And the other thing is there are a couple RFCs that I've read cover to cover in my career. So, I used to work on an API debugging tool, and we were implementing WebSocket support. And because I have what I would describe as back-end brained, so despite being a front-end developer, I've noticed that I think more like back-end developers tend to think in terms of how I approach things. I thought, I'll just read the spec. Like I'll implement a WebAssembly, a WebSockets runtime. I get them mixed up now, but I read the WebSockets spec from top to finish, which sounds like it's a lot, but it actually is not. And it's very approachable and readable. And I would encourage people to take that approach when you're trying to learn new things. Like you can read the whole WebSocket spec from cover to cover in a weekend and have a pretty good sense of what's actually going on and like what the data framing looks like and everything. And I think that those experiences set me up to be able to succeed reading the WebAssembly spec, because and I've also read the JavaScript spec a lot over the years, like doing, writing custom ESLint rules. You kind of need to be aware of the AST, and then you see these things like, what is an exotic object? Like I've written JavaScript for a long time. I don't know what an exotic object is. Well, it's actually a thing that's very common in the spec, right? Or same value equals 0 or whatever. There's these things, So I think all of those experiences teed me up to be just confident enough to look at the spec and just ignorant enough to not know what I was getting myself into. Yeah.
Oh, that's wild. I I know I've been watching a lot of Andreas Kling's stuff, and he's taking a very similar approach to their browser Ladybird, where all of the browser code is they're trying to implement it as close to the spec as possible. And they found just a ton of like incorrect spec and open bugs against the spec where it's either ambiguous or there's actually just a bug. Because a lot of the web is kind of de facto in a lot of ways.
Yeah. I have a great example of that, actually, that maybe people have hit. For many years, the JSON spec had a feature in it about the ordering of the objects, and it said, like, I think it used the word should, that engines should respect the order that properties are inserted, or like basically said it's JSON is not objects, it's actually not directly mapping. But the point is, for a long time there was this fight between the browser makers of, does the order in the JSON for objects matter or not, because the spec is it's written intentionally to be ambiguous about this, and it was not for many years. So Chrome would respect the order and Safari would not, and this has hit me many times in my career. It did in the early parts of my career, but they changed it. Now in JavaScript, there's this thing called for in order. Look it up. It's terrible. It needed to be done. Now it's consistent. So I don't want to poo-poo anybody who worked on the spec at TC39, which is happening now, by the way. But anyway, I get excited about any time the standards committees meet. But yeah, I mean, these things do change over time, and it can be very confusing if you're caught in the middle where the spec is ambiguous and therefore different implementers will do different things, and it's kind of unclear. Yeah. But what I did, actually, I can answer your question too in another way that I think is also interesting that I didn't explain in the original video. I'll be getting to that more in technical deep dives. But one of the things I did with my test suite is I ran the same tests through at least 4 times. So I would have this, like, A is 10 and B is 20, and we're testing addition. So what I would do is I would run A and B through as decimal numbers through a TypeScript only system that just doesn't know anything about WebAssembly. It just knows how to do addition because I'm testing that instruction. Then I would do it again in binary. So basically first you convert those numbers to binary numbers, and then you do it, and then you get your value, and then you convert them back. Okay. But then I did it again in JavaScript, binary and decimal. Same thing, but now in like actual pure JavaScript. But then there's 2 more. So this is 5 and 6, and these are the keys. So actually I said 4, but it's really 6. I did it in the WebAssembly JavaScript runtime with the same exact test inputs. And so this is the JavaScript runtime I spoke about before that you can, go in your browser and run Doom like a regular game. Well, this is the way in which I caught tons of bad assumptions that I had about what the spec actually meant. And I would read it and go, oh, that's what it means. Okay, like I thought I was like trying to make sense of how it was saying to do something. Because sometimes I would have, 150 tests and like 3 of them would fail. And if you've ever had a test suite like doing unit tests, that's really weird because like if something's wrong, a lot of them should fail, or all of them, hopefully. And sometimes there were like deep down assumptions about like, oh yeah, this number, as you get really close to, the 32-bit limit, actually there is some specific thing that you have to account for when you're handling temporary values and overflow units and things. So I hit these things because C is pretty freeform. Like in C, actually, I feel like I'm talking too much, but it's just, I think this stuff is so exciting. In C, overflowing is actually used, we consider, like we have stackoverflow.com, right? We consider it's like a joke that this is a bug. And often there are Stack Overflows that will create bugs, but actually in C, overflows are used as a tool. So overflowing is when you have a big number and it gets so big that you don't have any precision left. Like imagine I told you, write down these numbers, but only have 2 digits, 99, 100. And you're like, oh, but you said only 2 digits. And it's like, well, I don't know, figure it out. And so what C does, it'll go, okay, 0, 0. 99 plus 1 is 0, 0 because I only have 2 digits. And that's how overflowing really works. Well, here's a fun fact. In the Doom engine, there's no floating point numbers. So you might think about that for a second and go, wait a second. And I was surprised by this because I thought I would have to implement the floating point like IEEE 754 spec or whatever it is. Well, think about like your character pointing Doom guy pointing his weapon or whatever, right? Well, if you like wrap around, if you do a circle, you step around in a circle and you turn your frame of view. So you're rotating the player's frame of view. How does it track the like angle that you're pointing at? And the way they do it, I thought was really cool. And I've talked to you guys do some game dev stuff, so maybe this is going to be really boring to you, but I thought this was so interesting. They take 360, that number, which is degrees, and they spread it, they smear it over the entire 32-bit addressed space. So you have a 32-bit number, which 32 bits is like 2.25 billion or 2.5 billion, right? Is 2 to the 32. So they smear 360 over that whole range. So now 180 degrees is really, 1.2 billion. And 360, close to 360 degrees is 2.6 billion. It's just an integer. But what's cool is if you wrap around, guess what? You take advantage of overflow, and now you're back at 0.
That's so cool. That's so cool.
Right? So you can't go about this. Like originally I was like, I have to make sure it doesn't do any overflows. And I found out, no, it has to overflow. It won't work unless it overflows because there's parts of the engine, it's a feature. There's parts of the engine that use C overflowing as a tool, which I thought was just so cool. I don't know. Where do you see stuff like that in your normal day to day?
I don't know what they were thinking, but I imagine it was like, oh, we want this to run everywhere. So we can't rely on floating point coprocessors or floating point like hardware. Like at that time, like maybe that was a consideration. So like, let's just do integer arithmetic and, there we go.
I'm going to get fact checked here, but I learned along the way as well that a lot of people are not aware of this. I think C does have a runtime, which I never associated that. You hear about this concept of like Go has a garbage collector and a runtime, and that's why it's bad. And Rust is no garbage collector, and that's why it's good. But actually, Rust has a runtime. C has a runtime too. And my understanding is a decent amount of the stuff that the C runtime does is floating point conversions and things. So there is a like very tiny amount of stuff. Maybe I'm wrong on that. But anyway, blow us up in the comments if so. We'll appreciate the engagement. It's just like, there's these things that you just don't know, or maybe you thought you knew, and then surprise, C has a runtime.
Speaking of learning things, like what did you learn about like TypeScript in this process? Like I imagine like in addition to learning how like you're learning a lot doing this project. You're learning all about how WebAssembly works, all about how C works. And then now you're like, okay, I'm going to do this in TypeScript types. Like, what did you learn about TypeScript as you were doing this?
I was squirming a lot of this time to find a way to not have to do this whole project. And one of the squirm motions was getting out of doing binary numbers entirely. And in JavaScript, there's actually a really easy way to work with binary numbers. If you have a string and you put 0, I think it's 0b in front of like a bunch of zeros and ones, and then you do like you like wrap it with number. I don't know what it is because I'm not a real programmer, I promise. Like so I like sometimes I have to explain these things without like a pre-recorded video or something, as if people can hear me and see that like I really don't know what I'm talking about.
I feel like you're actively thwarting Dunning-Kruger right now.
Thank you. Well, maybe there's a way in JavaScript to make like really easily convert numbers that are binary to decimal. It's actually like really close to working in TypeScript, but it doesn't quite work. And it's the only, and I had a mission because I know because of the channel and other work we've done, I know some of the people on the TypeScript team, and I was like really adamant that I would not ask for any features in order to make this possible. Like that would kind of defeat the point of the project. It has to be vanilla TypeScript. So I found this thing that I thought like maybe was a bug that you can get halfway there. So you can convert a binary number to a decimal number, but you can't go the other direction. And I thought maybe this wasn't intended. And I found a bunch of behaviors where it does weird things at different limits. It switches to E notation at 2 to the 20 and 2 to the -6, which seems like random numbers to me. So anyway, E notation is like, 2E20 means whatever, 2 to the 20th or something. I submitted a bug and they looked at it and they go, no, this is here. Read the JavaScript spec. This is actually how JavaScript works. That's why we did it that way. And I'm like, dang it. Answering your question, I think there's very little that I really needed out of TypeScript. It turns out that TypeScript was capable of this back in 4.1. And for context, we're at like 5.8 today. I mean, it was like years ago was 4.1. I don't think the TypeScript part was really that amazing. There's a bunch of ridiculous types that are optimizations. So like things that, I have kind of pre-computed large things like how to add numbers together and stuff like that. Like there's a few lookup tables where it's like really basic binary stuff. But in the scheme of it, there's really not that much amazing TypeScript wizardry going on in the project. What there is tons of tiny paper cuts and building blocks and just tiny little pieces that got assembled together into this fluff that eventually can generate a frame of Doom and run arbitrary WebAssembly. But, at the end of the day, I think that a lot of people probably could do this. And I'm not I haven't tested this theory yet, but it's almost like a goal of mine to sit down for like 3 days with somebody who's like a TypeScript professional, has written TypeScript for like 5 years or 3 years maybe, and like has a good feel with it and understands some stuff, and like show them every single piece and get them to kind of rebuild it with only a few instructions themselves. And I think it's very attainable. This was sitting here in front of us waiting to be done for probably years, but it's a ridiculous, I myself didn't think it would be, it's a ridiculous goal to have, so I can see why nobody else had it.
I mean, that sounds like a fun workshop, actually. If you ever get a chance to pitch a workshop, that seems like a good.
Yeah, I'm thinking about it. Yeah, it would be, I did actually, well, I don't want to poo-poo anyone, but like, it was interesting. Like, now that the video is out, I think people understand it more. I did actually pitch this to a WebAssembly conference that it's already gone now, but yeah, they rejected it, this topic. And I think that one of the things that's difficult, and I'm not bitter about that. They can accept or reject whatever they want. It's fine with me. But one of the things I've noticed about this project is it's really hard to describe what's interesting about it if you're not even TypeScript developer, if you're not like a TypeScript nerd. You might like kind of miss the subtlety of what is so insane and like absurd about it.
Yeah, actually, I did want to ask about some of those types that you mentioned, because I feel like I remember some of them were like 100,000 lines long. Is that right? Some of those files. So how did you have to build a lot of little tools yourself to like sort of generate those files? Like, how did you make those files?
Okay, so there is like one little concession, and I'm nervous about describing this because I don't want anyone to get the wrong idea. I feel very strongly that this is like vanilla TypeScript, okay? But there is one thing I did to make it happen faster that I kind of automated my hovering over the mouse. There's a thing called people talk about these things, state machines. Well, a state machine is a amorphous topic, but what I basically built is a state machine, and the type is actually only one type. So like everything of this project is exactly one TypeScript type in the end. And that type is hundreds of thousands of lines long. And most of that is source code. Like around a quarter of that is source code, and 3/4 of that is just memory, just like raw memory values. Like this memory address has this byte value. That memory address has that byte value. And over time, what you do with the engine is you pass that type to the engine, which is itself another TypeScript type. That's the WebAssembly runtime. And it looks into it and goes, oh, okay, you have an instruction stack, just like I mentioned in the beginning of the conversation. And it goes, oh, the instruction stack is add. Okay, I know how to do add. I'm going to do add, and then I'm going to return. Meaning I'm going to take that instruction away because we did it, we're all done, and I'm going to do whatever the thing it said to do to modify the stack of values. So there's like a stack of values. So it'll do some work and then bubble it back up. And so this process happens millions of times. So I think in the end, it was like 18 million instructions or something like that. So that process, that like going down, doing tiny bit of work and going back up, going down, tiny bit of like new instruction back up, that happened over and over again. And what I did is I built a script that runs the type checker. So the JavaScript type checker the TypeScript type checker has a JavaScript API that does exactly the same thing when you run TSC. It is literally this. For many years, it used the same code path. They were like the same file. It just had a little wrapper in front that would give you a CLI experience. So I used that JavaScript API to go in there, type check the type, get a result, and dump it to a new file, and then go to that file. And I named them the result and the like input and output in such a way that it could just go in the file and look for that type, and it would be there. And it would go to there, and it would do it again. So it would just do like chunks of work. And I also built it up so that it doesn't have to do one at a time. I could have it do 100 at a time. So the type checker would go down, do 100 instructions, and then spit out its guts to a new file. And then, so that's, some people have asked, in the video it says 177 terabytes. To be honest, the number is a lot more than that. That's 177 terabytes. If you do 100 instructions per second, is about how many terabytes of code it was dumping to files over the 12 days that it took to run. But I guess it would be, I don't know, something like 100 times. What would that, would that be 1.7 petabytes of TypeScript types? It'd be something like that. Because you're copying over and over and again. Every time you have to do anything, you have to copy all of it, all over again, piece by piece. But I thought, well, whatever. 77 terabytes is big enough to make people laugh. It's, even if the real number is much bigger, that's good enough.
Well, you now have a form of like time travel debugging now, where when you have like you have these snapshots of the virtual machine. You know, like I mean, I get in the most insane case, you could go one instruction at a time, and then you could like time travel debug this whole virtual machine, which I would be wild.
Yeah, and that's actually, if you watch the video I was talking about, the final boss video where I showed me debugging something, that's exactly what I ended up having to do. Is I found out that like, I mean, it was kind of like narrowing the fence posts or whatever, that like, oh, I know that the fault happened at instruction 980,000, but I also know that that memory address was first assigned around instruction 700,000. So it's like, okay, I can just like keep moving the lower and upper bounds of that tighter and tighter until I find the single instruction. And because I'm not super quick, I did basically have to get down to a single instruction that things were off. And I did that by comparing the full, like literally the byte for byte memory values in the JavaScript runtime and my runtime. So like the memory layout had to be byte for byte exactly identical.
Well, that's awesome.
Yeah. I was going to ask, what was the most mind-meltingly part of this project? And I feel like it's that final boss memory corruption, was it that? Okay.
Yeah, I mean, I had been saying, like, sometimes I remember I had my friend, a guy I'm friends with, Sam Boyer, is, people in the TypeScript world don't know him, but he's famous in Go development, because he wrote DEP, which is this, before Go modules was a thing. Sam did this, basically imagine writing all of NPM by yourself. Anyway, it's not exactly that, but he did some amazing work in Go, and he's an extremely talented engineer. And, I had him over for a barbecue one day, and I brought him up to my office and I showed him this. And I remember telling him that, like, he's like, well, but what happens if, and I was like, stop, don't say it. I can't get to that point. Like, I can't get to the if it gets a million instructions in and it fails. Like, it's not an option.
Well, did the thought of like implementing your own debugger where you could set like a breakpoint on like a address right cross your mind?
I have it. Yeah, actually. So that part it was really useful to have early on so that the machine would, because you hit these situations where it's like, so digging a little deeper into the add instruction, you would think that it should have like parameters, that it should say like add A and B. Well, then like A and B should be parameters that are like kind of like a function that are like fed into the instruction, but it doesn't work that way. The way that it works is there's values on the stack, and the add instruction just pops two values off of the stack. And by convention, like sometimes it doesn't matter. I forget, there's a transitivity. Sometimes the order doesn't matter, like in addition, but in subtraction and division, for example, the order matters a lot. So the order is also another thing of like which order you pull things off the stack matters. But imagine you hit the situation where you have an add instruction and there's only one thing total in the stack. So you pop the first, all good. And then you go to pop the second, nothing's there. Well, what should the engine do in that case? I had to answer that question because it's a code path. And I realized, you know what? I could make a synthetic instruction. This is not part of the WebAssembly spec. I had like 5 or 6 instructions that are like this. I could make an instruction that just says halt. And anytime that instruction appears, I could put it into the highest level looping mechanism and say, pull off the next instruction. However, if you see a halt instruction and only a halt instruction, totally stop doing everything, just save your work, dump your guts, and, Dimitri's going to come look. So that's what I did. And so in the add, in all the instructions, all over the place, there's like an error mechanism where it will go, okay, I'm going to do my work, but if something goes wrong in the process of doing my work, like I just described, like there should be 2 values there ready to pull off. But if there aren't for any reason, then actually just halt. And I even realized later, like, wait a second, but the halt is all just an instruction like anything else. So like I have values that were temporary values at the time that I could stuff into that halt instruction. So I could also like, not only could I do debugging this way, I could do watching values this way. Because think about it like source code. If all you have access to is source code and you put a halt in there, that means if there's a loop, you can only halt, your only option is to halt in the first iteration of the loop. But what if the error happens way deeper in the 100th iteration of the loop? What do you do then? Because you can't have every iteration of the loop having that loop instruction. Well, you can basically put in logic that says, hey, instead of just halting if there's an error, actually check this value every time. And if the value looks a certain way, now you halt, and that's watching. That's now I've said, wait until this counter gets to 1,000 and then halt and give me all of the spill your guts and give me this temporary value. And so now you have like throwing. That's what throwing is, right? So I have errors, I can throw errors, and I put errors all over the source code. There's like stack exhausted was a common one, right? Because all the instructions pull values off the stack. So it's like, so there's lots of stack exhaustion errors all over the place. That is just like a completely bespoke thing that I made in order to like be able to debug this. And that helped a lot to be able to do like sort of little helper abstractions.
Well, it feels like you're ready to like be a C programmer right now. Like this just, you're ready to write a compiler, like, cause you did.
It's funny, like the reactions, I demoed this to like 55 people over the time and before it was public. And that's where some of the reactions that you saw in the video. And some of the reactions were like, but did you know anything about VMs before doing this? And you're like, no. And they're just laugh and just people are just saying, how could you not have, like, did you know? And I don't know. I didn't even realize that I built a WebAssembly runtime until after it was really doing stuff. Like it was really working. And like, it didn't even occur to me that like, oh, I wonder if this could run other things. And I would try other WebAssembly things and like, oh, that's interesting. It can do Conway's Game of Life. And so to me, like I tweeted in January of whatever, more than a year ago now, saying like something really amazing happened in the TypeScript world. And a lot of people were like, what is this? What's going on? And I was just like, well, you'll find out, but it's going to be a long time from now. And it ended up being more than a year later that I finished the project. But that moment that I was really excited about was when I was like, wait a second, I can write Conway's Game of Life in C. I can put it through the whole ringer that we talked about, the whole system, and let's see if it returns the result. And it did. And I was just so blown away by that. It was such an exciting moment. But that was really the last step along the way. We went from nothing to Conway's to Doom. There was really some people have asked me, why didn't you do Pokemon or, Tetris, something simpler? And it just goes back to that first point, because I didn't think that if your mindset, think about it from my shoes. If your mindset is you're just trying to find a reason this doesn't work, there's no sense in fooling around with Pokemon. Just go straight to the gold with Doom. Go to something really hard that has a lot of requirements and is very taxing. And there you're going to find the thing you're looking for about why it can't work very quickly. That was why I never did. I would like to kind of see somebody do Pokemon or Tetris. I think it would be a lot easier and it would probably work. But
yeah, this reminds me of the Primogen tweet where TypeScript types are a real language when they run Doom, and like, and then he responded to his own tweet. And he's like, I've been had or something.
Yeah, that was a funny moment. So if the project finished in, let's see, I always remember, it's funny, there's a moment in time for me, the last run of the project. So I said it ran in 12 days, but it didn't run the first time in 12 days. Like there were a couple 20-day runs where I had it running in my basement on a different computer, and it would be infinite looping, or so I'd find some problem or something. So I think there were like in total maybe like 12 or 15. I stopped actually counting and collecting data after like the 9th one, because I was just like, whatever, this thing sucks. I don't know what's going on. But I was collecting data, like very specific, like instrumentation data in the beginning. And the last run happened. My kids were all dressed to go trick or treating on October 31st, and I ran upstairs. I'm like, okay, I'm just gonna like start another one. It's probably gonna screw up, and that was the final run. We had just pushed go on another run of it after I fixed up some stuff and made some things nicer. And 12 days later, the rest is history. But along the way, there were many moments where I was really kind of like, oh man, is somebody else going to think of this? Because I realized that actually it's not hard from a TypeScript perspective. Like it was hard for a lot of other reasons, like we're talking. TypeScript is very capable of doing this a lot more than I think people, including myself, realized. And one of them was that Primogen tweet where he was just joking. And what he was responding to when he tweeted that was somebody did Flappy Bird in TypeScript types was the headline.
Mm-hmm.
But actually, and I have a longer video I'm working on that's taking me forever that I'll explain this in more depth. But like, no shade to that guy. I think his name is Zach Overflow. Go check him out. It's great. It's a cool project. But there's no sense in which that project was, quote unquote, in TypeScript types in the way that this was. Because what he did is he took the kind of the grammar of TypeScript and used that to write an engine in Zig that can execute those instructions. And then it runs in another language. It runs in Zig. So there's really no like TypeScript. There's like a file in that project that has like add, subtract, multiply, and it's just like add, angle bracket T, angle bracket equals T, because his machine knows to go look at that add instruction and do something separate. So it's like the logic wasn't implemented in TypeScript type. It was a cool project and I was really excited about it. But I remember exactly where I was. I was in my garage walking to my car, and I pulled out my phone after it was hitting my garage door, and I saw a headline that like someone implemented Flappy Bird in TypeScript types, and like my face went white, and I was just like, oh no, that's way cooler than Doom. I was so scared. And then I read into it and it's like, oh, okay, I'm still safe. But yeah, I mean, there were many points along the way where it's like, if I don't do this, somebody is going to eventually, because there are people that are nerding out on this kind of stuff, and someone will realize that this is possible eventually. Yeah.
Awesome. So now this is done. You're done with this. Is that right? Yeah.
Yep.
And so
Now I sleep.
Yeah, now you get to sleep. And then since it almost felt like the same week, we also got the news that TypeScript Go is going to be a thing. And I believe you had a little bit of a hint that was coming. So we're just wondering, like, what are your thoughts on TS Go, and how was interviewing Anders on your video?
I will say I actually showed the TypeScript team the Doom project before TypeScript Go was a thing. So for anybody out there, they are doing this so that TypeScript will run faster. It's undeniable, right? I'm just kidding. My thoughts on TypeScript Go, this is just another example of the best possible software team I think anybody can think of. That team. So I'm not a professional interviewer, and I actually got a great opportunity to interview Daniel and Ryan from the TypeScript team some time ago. And I told them at the very beginning of the call that I should never have said this. It was so stupid, but I told them that, and it's true, I was a diehard Flow guy. So there was a language that was an early competitor to TypeScript called Flow, and I was like super into Flow, and I really wanted TypeScript to burn in a fire and for Flow to be the thing. I really did not want it to be TypeScript. And actually in that video, we talked about why there's stuff about soundness and goals of the projects and other stuff, which was really interesting for me. But what is really, really great about TypeScript is not, to me, the language. It's not even the community. It's not even the NPM packages you can find. It's the team. It's such a good team, and I'm so glad that they're doing what they're doing. And they made a choice that is just so deeply pragmatic. And I'm so excited for TypeScript Go because I think they're doing it for all the right reasons. And I think that it's everything that TypeScript needed to do what it needs to do in the next 10 years. So we've had about 10 years up until now, actually more, but let's call it 10. And I think that it's just an exciting time to be alive. I don't know. I don't think I'm going to be right. Like I've been, Rust developer, so I'm trying not to alienate my own audience. But the reality is I prefer to write anything I can. I write it in Rust, and I have for a few years now, longer than Michigan TypeScript has existed. I love the type level programming, and I love, making, Michigan TypeScript's whole goal is to make stuff for like library authors and people who are kind of at the advanced end, because there's so many resources and it's so easy to find them for like beginners and intermediary content, but there's not as much in the other end. And I feel really passionate about that. So I don't really care that it's TypeScript that I'm doing that for. I think that it's a big need and I like filling it. However, yeah, I mean, that's my feeling overall on TypeScript Go. I think everybody thought that Rust developers would come out with their pitchforks, and their fists raised to the sky. And that didn't really happen. Actually, Rust developers were like, yeah, makes a lot of sense.
Mm-hmm. Mm-hmm. Yeah. No, and I think they did a really good job of explaining the reasoning, because I think a lot of folks that maybe had a surface level understanding of what was happening might have been questioning the decision. But I think, looking at a project like that is, very mature and old, you really do need to have like a bug for bug implementation in order for it to be successful. If you're going to go switch a language that it's written in, if you decide to rewrite something from first principles, you're going to have a whole list of new bugs and new behavior that were completely arbitrary in the previous version of it. So like, I could totally see why they went like, okay, Go has similar loosey-goosey semantics to JavaScript and TypeScript. Porting is very possible in that realm. So it really made a lot of sense.
And I was really glad I was very touched and honored that they gave me the opportunity to, interview Anders ahead of time. I had been pressuring them for a while, so I got a little bit advance notice. So the reason I got advance notice of TypeScript Go actually has nothing to do with Doom. It's because I also run a conference. So we have this conference, Josh Goldberg and I started SquiggleConf, and Squiggle is all about dev tools and tooling makers and library authors and those kind of things, and cross language as well. So it's not just about TypeScript. We have people from the Zig camps and Go camps and a lot of Rust developers and stuff. So it's web tooling, I think, is kind of the only way to specify further than dev tools. And Jake Bailey from the TypeScript team was kind of slated to be on the conference because of the TypeScript Go project. He wanted to talk about it, and that we thought that was a really good match. And so I needed to kind of like, he came to us with like, hey, I got this thing, but you can't, you have to had to sign an NDA and all of that. So that was the reason that I knew. It wasn't because of anything Doom related. I would have found out like the rest of us. But it was cool. But during that process, I kind of told them, hey guys, you really need to do a flippantastic job on the DevRel side on this. You know, the TypeScript team doesn't have a kind of like dedicated DevRel person. They used to have Orda Thoreau, who was amazing, but that was a kind of temporary arrangement in the beginning anyway. He didn't get fired or something. It's just he was there to do a specific thing with the handbook and went on to do other. He has a company called Puzzmo now, which is super fun, by the way. Check it out. It's a bunch of little puzzles and New York Times crosswords and those kinds of things. It's a really cool idea, and I'm very happy for him doing that. Yeah, I was just kind of pushing them that, you know, you really need to, it doesn't have to be me. I don't care. Talk to anyone, please. There's lots of options. Like, it's not about me. It's just like, you have to do some interviews with people that are an hour plus long to get out some of these questions. And when they, you know, contacted me, which was just a few days before the launch, saying, hey, we'd like to, you know, Anders and, you know, we'd like to interview on this. I was just like really doing my best to think of questions that library authors would be having about it. And yeah, I think the launch went really well. So props to the team, and I'm very excited for this. We should all raise a glass for how they handled that and how the next chapter is unfolding. It's very exciting.
Yes. Yeah, we can cheers virtually. We agree. They did such a good job on that. Communication strategy was so good. And I mean, your interview was fantastic. And
Thank you.
I listened to the Syntax FM episode with Anders and Daniel. It was also fantastic.
It's funny, like I listened to the Syntax FM one as soon as the launch happened because, you know, of course I already listened to mine. And it was really interesting to listen to like two different approaches to because I realized in retrospect, like I was very serious and very like, let's, you know, like make sure we get through all the questions and stuff. And they were just like having fun. And it's a very different approach. And actually, I enjoyed listening to theirs a lot more than I did listening to mine, but not because of me or them. I'm just saying just because of the way that they did things. And it was an interesting lesson for me on like what makes that podcast and Wes Boss and, you know, those people so absolutely engaging to listen to. Michigan TypeScript has no goals. And I should say, I am not Michigan TypeScript. Michigan TypeScript is a lot of people. I think in 2023, we had like 60 people on the channel. I think it's like a collective thing. I have absolutely no aspirations of being a YouTuber or something. It's not interesting to me. So I wish somebody else would do it instead of me, actually would be nice. But, you know, maybe someday if you're out there listening, please contact. But yeah, it's cool to hear different ways of approaching things. And, it's nice that was also a part of the launch.
I appreciated your interview with Anders because I'm a very detail person, like detail oriented, and and in fact, a lot of people have to tell me to like pop the stack and get to the bigger picture a lot of the times because I will go straight into the weeds.
Right.
But I do enjoy like understanding the details of like why not C#, why not Rust, and like these are the constraints that we're working in, and that having the very specific detail really helped me. Like it really helped.
Ended up being. That why not C# ended up being the greatest gift of that whole video. If you look at the analytics on YouTube, it's like a huge peak right at the moment of that chapter. And what's interesting is like the syntax guys also asked him that, but Anders kind of shrugged it off. And I asked him that and he shrugged it off again, but I asked him again. I asked him twice. And the second time is when we got like the more in-depth answer. And what I think is really interesting is like, that's what people ended up really wanting to know. Like if you go on the TypeScript Go discussion board on that topic, actually there were not Rust people being angry. There were C# people being angry and saying like, this was the moment, this was the chance. How could you do this to us? And, you know, they were very upset. And I think they have some reason to be. It's understandable, but it was an interesting lesson for all of us because, I mean, I don't mean us, the TypeScript team. I mean us. I don't know what they think, but I think it was an interesting example of how separate the web dev community is from those ASP.NET or C# people, because I had absolutely no context for how they might feel or what they might think of this. And they came out of the woodwork in droves, sharing their opinion, which is good. I think everyone was respectful or whatever. But it was interesting that like, wow, I really am like web dev itself is. I sometimes tell people like, you know, the vast majority of websites don't use React. Okay. And the vast majority of React websites don't use Next.js. Like we get very focused on the thing that's really exciting in this moment, but there's lots of WordPress sites out there. Okay. You're like, we can't forget about them. They are there. So yeah, it's funny.
Awesome. I think one of our last questions, just to have a really nice wrap this up in a bow, is what did you learn from doing this project and how are you bringing it into your future work? How are you bringing it into Michigan TypeScript? How are you bringing it into SquiggleConf? Like what did you learn about yourself that you're sort of bringing now into your future work?
Well, it's downhill from here for the rest of my career. I think I'm very pleased with that, actually. If this becomes the thing that I'm known for, I'm kind of like ready to embrace that. I don't think I'll ever do anything. I can't imagine doing anything this cool ever again. And I'm happy about that. But it was kind of like being in the right place at the right time. You know, it was a lightning in a bottle situation, but lots of other people could have done it other than me. I just happened to be the one. I think what's interesting is how almost every day, I don't want to say every day, but 3 of the 5 days per week, something comes up for me at work that I learned on this project. You know, after I was looking for a job in the beginning of working on this and kind of in the middle of it, I got a job that I'm very excited about. And there's a lot of TypeScript going on at this company, and they were having performance problems. And I like jumped in and was like debugging the TypeScript compiler, and I was like doing all this stuff. And they were like, "Who is this guy? What the hell?" Like, I got a lot of credit for it. And in my mind, I was like, the only reason I know how to do, because some people ask me like, "How do you even know how to do this stuff?" And I couldn't tell them because I'm like, "Well, there's this Doom project." No, I didn't. So it wasn't public yet, and I didn't want to like spread too much the word. And it was funny that like, wow, I felt really good because it's like, wow, I'm providing a lot of value to my company. I'm doing something that not even nobody else could, but like nobody else has. We could just put it that way very objectively. And it feels really cool. And so I think that's why, you know, I want people to remember from this project is that personal projects give you a level of engagement with the concepts that you cannot synthesize at work. It's inappropriate for you to synthesize at work anyway, because your job at your job is to do the efficient thing. And if there's an off-the-shelf tool that can do it, you definitely should use that off-the-shelf tool. It's battle tested. It probably has better security than anything you'll come up with. Like, that's the right choice. But if you really want to know like how the whole stack hangs together, how it all fits in, there's nothing like a personal project that has no point. There's nothing like something that's just for fun, to just enjoy the journey. And that's what this was.
That's so awesome. Yeah, I'd say that's true of a lot of stuff. If you want to know how a thing works, build one. And you know what? Yeah. And it doesn't have to be the best. And it doesn't have to be perfect. And like, you know, one thing that I'm trying to live right now is to not let perfect be the enemy of the good, and just do things. And, you know, like you said, I think you'll be surprised what you can do.
In my house, I do the laundry. And the reason is a really weird, simple reason. My tolerance level for how big the laundry pile should get is just barely below my wife's. So my wife would definitely happily do the laundry, right? But like, I see the pile and I go, time to do laundry based on the size of that pile. But it's not like it's that different. It's like we're talking like the difference of 3 socks, okay? It's like right on the line. But sometimes if you could put yourself in a position, I bring that example, hopefully it makes sense to say, like, if you can force yourself to do just a little bit faster than you can force yourself to stop and like really think about whether you should, sometimes that can really save you, and you can be very efficient, and you can, you know, like you can just get a lot of stuff done if you can like just do it. Stop making a big plan, and just like there's time for planning, but it's not all the time. Mm-hmm. Just do stuff, and sometimes something really unexpected will come out. And I'll close by saying, like, on the topic of work ethic, one of the comments I got that I thought was really interesting on Reddit, someone was saying, like, I was talking about burnout, and I was very burned out for a variety of reasons before starting this project. And I thought I was actually getting to the point of kind of leaving the profession entirely. And then someone said, kind of weird that you solved your burnout by like programming for 18 hours a day, like a machine, you know, like, and what I say to that is, this project had tons of points where it was like little problems that I had to solve that I felt really good about solving. And to me, that was super regenerative. That was super rejuvenating to get through that and to like, imagine the feeling of thinking, no way will this thing that I'm in front of be possible to get through. And then later that night you get through it. And then you do that every day for 6 months. It was awesome. I feel like a completely different person. This project set me up for the next, I don't know, I mean, hopefully the rest of my career. I got a lot of energy out of this. So even though I was working really hard, I think burnout is when you're working on something and it might not even be hard, and you don't get what you perceive to be a result.
Yes. Mm-hmm, mm-hmm. Yeah. In fact, I think one of my favorite quotes is, burnout is the result of a failed strategy, or like a strategy that's not working. And I mean, I felt the same way when I was, you know, at my job and then I quit. It wasn't because it was a bad job. It was a great job, great people, and fun projects, but I just wasn't getting that same level of like challenge, or like trying to balance, you know, working with kids and stuff like that was just really hard. And then I quit, and you would think that that would cause more burnout, and it did for a little bit because my strategy wasn't working. And then I switched it, and now it's much better. Now I don't feel burned out at all.
I love it. Yeah, totally. Well, yeah. Thanks, guys.
But where Where can people find you? How can they get a hold of you? See what you're up to.
I mean, I'm on the Michigan TypeScript Discord. I think that's a place, but I've never had any social media. I never even had a Facebook. I'm very proud of that nowadays. But in the beginning, people would say, you moron, how come you don't have that stuff? It's just not for me. I think social media is, an acquired taste in my opinion. But unfortunately, that's really the only way you can reach to me there. You can email, I think you can email anything at michigantypescript.com. So info@michigantypescript.com will arrive at an inbox that I can reach. And I mean, it's cool to do the Discord thing. So I'd say that's probably the best place. Yeah.
Wonderful. Well, thanks so much for joining. We really, really appreciate you coming onto the podcast. It was a delight to hear about your story.
Thank you. And good luck. And I hope you guys see this through and keep doing this podcast. I've enjoyed listening to a few episodes, and I'm really excited that you're putting in the effort. This is something people really need.
Thanks.
Yeah.
Awesome. We really appreciate it. And I'll say I'm a little starstruck. So
don't be. But all right. Thank you so much, guys. I'm very happy that you're doing this again. And thank you for doing it.
Perfect. Thank you so much.
Yeah, thank you.
All right. Talk to you later.
See ya.
Bye.
Bye-bye.
TypeScript FM is sponsored by Excalibur.js, the friendly TypeScript game engine for the web. Like many of you, I got into computers because I loved video games and dreamed of making one, but game development always felt a bit intimidating. Instead, I built a career in web development, though that dream of making games never really went away. Then I met Erik, who showed me I could use my HTML, CSS, and JavaScript skills to create games with just a bit of game design knowledge and the right engine. Excalibur.js makes game development approachable, offering everything you need to build 2D web games. Arcade physics, sprites, animations, input support, and integrations with tools like Tiled and AceSprite. It's beginner-friendly, yet flexible enough to grow with you. Our team has published 10 games using Excalibur, all written in TypeScript. If you're a web developer looking to dip your toes into game dev or sharpen your TypeScript skills, give Excalibur.js a try at excalibur.js.com. Click the big tutorial button to start building your first game, Excalibur, a Flappy Bird clone. After that, join our friendly Discord community of web developers who love to help each other and share game dev tips.
All right, news for the week of April 7th. Zod 4 just dropped, the beta did, and it's got a lot of cool features.
Yeah. Tell me about Zod, because I don't know that much about Zod besides using a little bit of it, for doing some runtime validation. But what's the big thing about Zod 4?
So Zod 4 basically is an improvement in many, many categories. I think they said 9 of their 10 most top voted issues were included in Zod 4.
Nice.
So a lot of things that a lot of people have been asking for a long time. There's smaller bundle sizes. There's error pretty printing now, which if you've been using Zod, that's kind of a pain point. And that's a pain point for me in my stuff. I'm definitely going to be switching to the beta even just so that I can have that pretty printing. There's file types now. So if you're accepting form data, file form data, you can verify that, I accept this type of file. I accept this kind of stuff for
That's
file
cool.
types. Yeah. And this one I actually ran into as well. They support recursive types, because before you kind of had to do some hackery to make it work and it was kind of heinous. Now you can do recursive types proper inside of Zod. There's also some more advanced support for what I call Booleans, which is you have a string, but you need to treat it like a Boolean. They have a lot more stuff around that. So you could have Y as a true or N as a false, stuff that, is above and beyond treating the type coercion in JavaScript as true or false, that kind of thing. And then they also have a top level JSON schema support. So built in first party JSON schema support. So you can emit a JSON schema from your schema, your Zod schema, which is pretty cool. And I think if you want to know more, check out Matt Pocock's video. He does a really good overview. And then there's also a tutorial from Matt Pocock for Zod 3 that we'll link here as well. But they have a blog post about it. I really recommend reading it. It goes really in depth with all of these features.
That's cool. I will probably be using it pretty soon once I start working on my Quick City course, because that heavily uses Zod for doing server-side form validation, and I'm sure that's one of the topics I'll be covering. So I'll definitely be diving a little bit more deeper into Zod. So that's cool. And I'm sure I would love to show an upload file demo. And so that sounds cool that I'll be able to show how to validate uploaded files. That's pretty neat. Another cool thing that I saw, if you're in the Laravel ecosystem. So our PHP fans out there that are also writing front-end TypeScript, the Laravel team released the first beta of something called Laravel Wayfinder, which is, I'm quoting from their blog post, it's a new first-party package that bridges your routes between the front end and the back end. So it bridges them with TypeScript. It automatically generates fully typed importable TypeScript functions for your controllers and routes. So you can call your Laravel endpoints directly in your client code just like any other function. No more hard coding URLs, guessing route parameters, or syncing backend changes manually. So this is really cool. You know, the funny part about this is that I do the same thing in my ASP.NET app, but it's all manual. But I'm using a extension called Typewriter, which lets me write templates that can read my C# code like through reflection, and I can generate a text template that then generates TypeScript code. So I have the same thing where all my routes are fully typed, all my controller methods are fully typed, but that was something that I had to write myself. But Laravel is going to be doing it as a first-party package, so that's pretty sweet. Do you do something similar with like your Angular backend apps?
You know, I haven't, but I think I remember doing this exact thing with Typewriter at General Mills. Like we did this at General Mills where we used Typewriter to like effectively emit a client. Like it's like you're doing old school open, was it OData, where you're generating a strongly typed client based on an OData endpoint or based on a, heaven forbid, SOAP endpoint.
Yep.
You know,
but it's super handy if you're not doing full stack TypeScript, because if you're doing Next.js or React Router or anything else where your backend is typed in TypeScript, you don't have this problem, right? But if you're using a different language like C#, PHP, etc., like you need a way to not have to hard code URL parameters and things like that. So that's a solution. So that's pretty sweet. We got some cool community news too. What do you see? What came across your table?
Yeah, so the first thing was a post from Dan Abramov, famously from React, has a great post about React for two computers and also a conference talk about that. And it's kind of like helping you to understand how React server components actually work and how like this two-step kind of execution works. It's a very long blog post, but definitely check it out. It's kind of untangles maybe some of the mystique and magic of it, and it really makes it more clear. It kind of lays it out straight. So definitely check out that YouTube video, and for even more in depth, check out the blog post.
Yeah, I love Dan's blog. I mean, it's like a lot of his essays. It's very detailed, and I think a lot of us really appreciate knowing the details. So if you are confused a little bit about how React Server components work, you definitely want to check that out. Our good friend, Dr. Axel, has been churning out sweet content. He's got a testing types article, which I think you checked out. And then I checked out his deploying TypeScript blog post where he talks about ways to package up your TypeScript for deployment. And we will have a future episode on like where can you deploy TypeScript apps. But his blog post is a great sort of prerequisite to that, which is how do I generate declaration files, source maps, how do I package things together so that I can distribute them. And actually, I think Erik, in a previous episode, you asked about like how do I how do I create a TypeScript package that I can distribute and share with other people? And so this is a good blog post that talks about that. And for testing types, I think we also want to do a deep dive into that. But was there anything cool that you learned from that one?
No, one of the things that Axel pointed out in that post is that because the TypeScript type system is Turing complete, it is code that we should be testing. And there's a couple strategies in that post about how you can go and test your types today without anything fancy pants, and then maybe some recommendations for the future. But definitely check out that post. I definitely agree. It's, as a person who has accidentally broken their public types for people to consume, it's a way that you can break your API. Your public types are a public API.
I feel like that's something that is not immediately, that's not something that I would have immediately thought if I was writing TypeScript. And it's not something that we've really done in the past on big projects before. Like at Target, I guess we did write a few like type tests. So I will say that. But it was more like we consume an API spec and test those declarations and make sure that they work. I like that this perspective of like, hey, in addition to maybe unit testing my logic, I should also be unit testing my types. And especially if I'm a library author, I doubly want to do that because as soon as I change a type, that's a public API that could break.
You got it.
Cool. Another cool thing I saw on Reddit was one of the top voted posts this past week was an article from Pipe Zero, and it's called Never in TypeScript. And they go through how the never type works and like how to think about it, which I think is kind of nice. So it sort of goes through like, if you think about TypeScript types in terms of mathematical sets, it sounds more complicated than it is. But they go through a few code samples of like, how does the never type work? And the little summary that I want to read out loud, which I think really solidifies it in my mind, is it says, while any, the any type, is the set of all values, never is so specific that there is no value that can be assigned to never. Never is the empty set, a set with no values. So I think that that is kind of a nice way to summarize the difference between like any and never. But they also cover like, how does unknown work? Like, what's the difference between any, unknown, and never? So definitely go check that blog post out. And I'd never heard of the phrase distributive generics. And that is a secret of the handbook, I think, today, is to go check out when does a generic become distributive, and it's when it's used in a conditional type. And so I think that was sort of a mind-blowing type of aha moment there. You got some cool stuff too that you saw?
Some cool stuff, and this kind of came out of the talk that I gave last week about learning shader programming, and I mentioned kind of offhandedly that you should check out the Sebastian League videos about rendering text and how deceptively challenging it is to render text like for a screen. Like, we take it for granted all the time because we type all the time and text just renders, but there's so much engineering that needs to go into like taking a true font file and then actually producing a glyph on a screen is a lot of engineering and a lot of hackery. So I definitely recommend that. And then another video that he did recently was simulating a CPU. And that just kind of lit up some parts of my brain, and I just really enjoy his videos. So definitely check those out.
Nice. Well, we heard in Dimitri's interview, one of his final bosses that was a huge challenge when developing Doom and TypeScript types was debugging memory corruption. So Jared Sumner, who's the creator of Bun, who we did an episode on, has a really nice blog post on debugging memory heap snapshots with V. And so I'll link to that. But he goes into some detail of how to use the V8 developer tools to actually think about and like work through debugging memory heaps, which is not something that we do every day. But man, I can tell you, I have to routinely destroy an end task for my browser all the time because these tabs use up so much memory. And I feel like if we as like front-end developers can skill up in like memory debugging, which I don't have a ton of skill in that, but I think that would be super helpful. And it's especially helpful when you're doing game development because you have such a long-running like process. I feel like one of the major things that we run into in game dev is someone playing your game for like 3 or 4 hours and then it crashes because of a memory leak. Well, it really pays to understand like how memory works and like trying to debug JavaScript memory. So I think we definitely want to check that article out.
Yeah. For giggles, like that type of testing where you let your game run for a long time to find like leaks and issues like that, it's called a burn test. Burn-in test. I
feel like we might need to start doing burn-in tests for our web apps, especially just because they're running so much JavaScript on the front end. I mean, maybe, we might be moving towards a world where there's more stuff happening on the server, but there's still going to be stuff that's, running on the client. And especially if you're using frameworks that allow you to sort of resume on the client. So like they start on the server, resume on the client, and there's no page reload, once the user renders the page, then I think that burn-in tests, might still be super helpful. The other cool library that I saw, if you are in the React world, you'll probably enjoy this one. This is called Animate UI, and it's made with Tailwind components, TypeScript, and React, and it's built on top of the Motion library. And these are basically copy-paste components that are like animated. So they've got all the styles and stuff applied to them, and they're in the right HTML structure or JSX structure for React. with all the state management and all that for you. So for example, if you want a dialogue that's like really nicely animated, you can just copy paste it into your project and customize it. They've got popovers, they have toggle buttons. I mean, they have all sorts of UI. And so I thought that was pretty neat, and it's totally free and open source. And it looks like they keep adding components all the time. So I think it's just a really nice resource. And I'm eyeing this one because I think for Keep Track My Games in its next iteration on the front end, I would love to like spend a little bit more time adding some animations and making it kind of nice looking and smooth, fluid looking.
Yeah. Maybe for your next game.
Yeah, maybe for your next game. I guess if you can use HTML UI and you can make it feel like it's part of the game because it's animated.
That's right. That's what I was thinking.
Awesome. Cool. Well, I think that's a wrap on the show.
I think that's a show.
Sweet. Well, it was nice talking to you, and it was great time interviewing our guests. So I hope you enjoyed that. But until next time, we'll see you later.
See you later. Bye.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to typescript.fm, where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at comronicus.com, and Erik is at erikonerheim.com. You can also follow the show directly at typescript.fm.